Hello, during this demonstration, we're going to be showing you a live migration of vMotion over a long-distance stretched ACI fabric. So let me first start by introducing the topology that we are going to utilize for this demonstration. So we have a single ACI fabric that's stretched. That means it's deployed in two data centers. So our fabric has 4 spines, 2 spines in data center 1, 2 spines in data center 2. And we have 8 leaf switches, 4 in data center 1, 4 in data center 2. One of the innovations that we're going to be talking about during this demonstration is the fact that the ACI fabric is interconnected. A leaf in data center 1 is interconnected to the spine 3 in data center 2 through EoMPLS layer 2 pseudo I/O. So from the leaf perspective, it has a 40 gig port going to an ASR 9K that then has a 10 gig link towards the other ASR 9K. And then we are running a EoMPLS pseudo I/O to cross connect the 2 ports. So between leaf 4 and spine 3, they think they are directly connected. And the same is true between spine 2 and leaf 5. However, it's also important to realize that we have validated the ACI Stretched Fabric when the links between the data centers have up to 10 milliseconds round trip time, which would allow you to deploy this solution when the data centers are located up to 800 kilometers or 500 miles apart. So during this demonstration, what I would like to show you is this single ACI fabric stretched and interconnected with, in our case here, with a EoMPLS that's going across a 10 gig link with 10 milliseconds delay. The starting point of our vMotion demonstration is we have 2 servers, 2 VMs, 10.14.101 and 10.14.102, both located in an ESXi host that's physically located in data center 1. We're going to go through during the demonstration, do a live migration of one of those VMs. So before I go ahead and do the migration, let me spend some time here just showing the topology. So first, I just logged into the APIC GUI, the APIC GUI. First, let me go here into the fabric and show you the topology. So when looking into the ACI APIC topology, you see the topology that I had previously demonstrated into the diagram, except that from the ACI perspective, leaf 4 thinks that's directly connected to spine 3, and vice versa, spine 2 thinks that's directly connected to leaf 5. But you know that in reality there is a EoMPLS extension. But as you're gonna see as I summarize the demo, the interconnections between a leaf and a spine could be using EoMPLS, dark fibers, or DWDM. So in this example I have EoMPLS, but from the APIC, from the ACI perspective, they think it looks like as the devices leaf 4 and spine 3 were directly connected. So we have here the 4 leaves in one data center, 4 leaves on the other data center, and the 4 spines. This particular topology here, we have validated that with a very large scale, when it comes to the number of tenants, when it comes to the number of endpoints as well. So to give you a reference, because to show that this demonstration we are doing with a scenario that's really emulating a real-world deployment, I have in the background traffic generators that are simulating up to 10,000 endpoints connected to this fabric. To show that, let's go to spine 1, goes into the endpoint database, and then what you see here is some of the endpoints that are interconnected to the fabric. And you see here that we have just above 10,000 endpoints connected to the fabric. What I'd like to do now is to demonstrate to you the latency, the 10 milliseconds round trip time latency that I talked about. So first, let me come here into Fabric membership, and then let's log into leaf number 1. So leaf number 1, when you log in here, you're first gonna be into the APIC, then I'm gonna SSH to leaf number 1. Okay, so I'm now in the console of leaf switch number 1. If I go back here, all I want is to get the IP addresses of some of those leaf switches. So for example, if I take the IP address of leaf 2 that's located in the same data center as leaf 1, and we do a trace route to that IP address 10.0.104.90, you're gonna see that the trace route, the paths resolving in a few milliseconds, the time to go from leaf 1 to leaf 2. So in 500 milliseconds, 0.500 milliseconds, I should say. Now, if I do a trace route to, for example, leaf 7 or leaf 8 that are located on the second data center, so I trace route. Let me just bring this up here so you can see better. I trace route to 10.0.144.95. So that's the IP address of leaf 8. What you should see is that we now gonna cross that data center interconnection link that has the 10 milliseconds delay. So you see here that as I am exercising the multiple paths, when I go to the switch on the other data center that are actually crossing that data center interconnection link, I have more than 10 milliseconds delay between on the path between the switches. Let me now go here and go into the vCenter and demonstrate to you that the actual live migration. So first, I'm going here into the vCenter, and at the moment I have both web servers 1 and 2 located on the same host 129.11 that is in the first data center. So if I would go here, let me just log into the VM config. So this is server number 1, so 10.14101. If I would ping 10.14102, which is the second server, you're gonna see that the response time is in 0.2 milliseconds. If I go here into the console of web server 2, and we confirm this is 10.14102. So if I would ping 10.14101, also the response time 0.2 milliseconds. The last thing that I want to show you here before actually doing the migration is to show you that through the integration between APIC and vCenter, the APIC administrator can actually see here where the VMs are located. So if I come here through the integration with vCenter, hypervisor 1.2911, it's the IP address of the actual ESX host, goes into virtual machines, and you see that I have web server 1 and 2, exactly how vCenter was showing as well. Okay, so traffic is running between them. They are located in the same data center at this point. Let me go ahead and migrate server.2. So come here, migrate, change the host. I'm now going to select a host that is into the second data center, 1.29.21. IP address, finish. So it's normal, take a few seconds before the live migration actually happens. So it's just copying the data. So migrated. Okay, so server 2 has now been migrated to data center 2. And you can see here that immediately now the round trip time, the delay to communicate from server 1 to server 2 goes to the 10.5, 10.2 milliseconds. And likewise, let me just reopen the console here of server 2. We should also see that the server 2 has connection to server 1. It's preserved the connectivity, and the time is 10.5, 10.4 milliseconds, showing that they are now located on two different data centers. So you can see here now the VM1's in data center 2. So web server 2 is in data center 2. Web server web server 1 is in data center 1. So with that, I just like to summarize what we demonstrated. So we have done a live migration, a vMotion, over a long distance stretched ACI fabric. So it's a single ACI fabric that's stretched across both data centers, and that is up to 10 milliseconds round trip time latency between the data centers. So the data centers can be located up to 800 kilometers or 500 miles apart. The data center interconnection technology could be dark fibers between the leaves and the spines, could be DWDM, or could be Ethernet over MPLS pseudo-wire. And as you saw here with Ethernet over MPLS pseudo-wire, the inter-data center links can be 10 gig. With vSphere 5.5, the same vCenter is managing hosts on both data center, and it's fully integrated with the APIC. Thanks for watching. For more details on ACI, please go to cisco.com/go/ACI.